Find the charge appearing on each of the three capacitors as shown in figure. Now this question can be easily solved by the concept that if the two capacitors are in series, then they will be having the same charges on their plates, and if the two capacitors are in parallel, then they will be having same potential difference across their plates. Now if we had to calculate the charge on each of the plate, so first we have to calculate the C equivalent of the circuit. Now if these two charges are in parallel, so the equivalent C equivalent of B and C will be easily calculated as they are in parallel, so the capacitance will be straightly add up, that is capacitance of B and capacitance of C, which comes out to be 8 microfarad. Now to calculate the equivalent of A and equivalent of B and C, that is C equivalent of the net circuit, then that can be easily calculated as this 8 microfarad and this 8 microfarad are in series now. So the series equivalent can be easily calculated by 1 by C equivalent as 1 by 8 plus 1 by 8, which comes out to be 1 by 4. So C equivalent of the circuit is 4 microfarad. Now the Q net can be calculated by Q is equals to C equivalent into V. We have value of C equivalent as 4 microfarad and voltage is 12 volt, which comes out to be 48 microcoulomb. Now since we have calculated the equivalent of B and C, then our circuit would look like this, with a battery of 12 volts. This is our A capacitance and this is the equivalence of B and C. Now since they are in series, and I told you earlier that if the two capacitors are in series, then same charge will appear on the surface and the charge will be equal to Q net. So QA will be equal to 48 microcoulomb. Now the 48 microcoulomb that appears on the C equivalent B and C will be distributed on B and C with respect to their voltage. Now since the voltage on both B and C will be same, so the charge appearing on them can be calculated by QB is equal to capacitance of B into voltage. This voltage will be equal to, let's CB, and the voltage will be equal to total voltage, that is V total minus voltage drop across A, because we had the total voltage over here, so some of the voltage will be dropped across this and some of the voltage will be dropped across this. And if you look in this diagram, let's say VA potential is dropped across this capacitor, then remaining, that is 12 minus VA, will be dropped across B and C. Now since B and C are in parallel, so the potential between both the plates will be same, that is equal to 12 minus VA. So we have CB as 4 microfarad, V total was 12, voltage A comes out to be 6. This VA can be more calculated by Q by C, that is charge is 48 microcoulomb and we have capacitance as 8 microfarad, which comes out to be 6 volts. So on solving we get 4 microfarad into 12 minus 6, that is 6, which gives 24 microfarad charge. Similarly on QC we can get 24 microfarad charge. That is the answer.